Okay, hello, welcome back. We're on our next video for talking about measures of central tendency for our statistics. Let's get right into it. All right, so here we are looking at page 17. So we're moving into measures of central tendency, where we are going to start looking at how our data is going to be used, again, with our frequency table and then in other measures or ways. So the measures of central tendency, when we're looking at that, we're looking at the where the middle of the data is. So these four forms is what we're going to focus on in this particular part with our measures of central tendency. So this is talking about where is the middle of the data. We've heard these values or these definitions of words before, where we talk about the mean, the median, the mode, and the mid-range. Okay, so here we are looking at each one. So we're looking at the mean first. The mean for us, we're talking about the average of something. So the mean, talking about in the mid, right? The average of things. We talk about the average of our grades. We're talking about the average sometimes of our checks and how we're going to get paid. It just depends on your job. All right, so our mean. We're talking about the average. So here's the formula that we're going to use. So we know X bar, you probably have heard of this or seen it before. So X bar represents the mean. So that's an X with a bar on top. So this is our mean. Okay. We're going to look at two formulas. It depends on what we're looking at as to which one we're going to use. Okay. This is our standard formula. Let's talk about that one first for our mean. Mean says that we're going to take the sum, seen this symbol before, the summation symbol, the sum of our X values, and then divide it by our N. And we just talked about what N means. N is the number of our data items, right? That hasn't changed. And remember, that is not going to change, okay? Or we're going to use this formula again. This is our mean. But this is the mean that we're going to use for our frequency distribution table, okay? But they still have the same part. So we still got X bar. They still have the summation, okay, where we're going to add some stuff. What are we going to add? We're going to add up the X's here. That's the data. Okay. Here we're going to add what? The data times, okay, so there's a multiplication sign. Okay. So multiply times what? This right here is the frequency. We just did the frequency. We just introduced that, right? So the frequency. Okay. Then all divided by what? N, we said, of course, we know is the number of pieces of data. Then F is, again, the number of pieces of data. How do we know? That's the F, that column I said, when we total it up, that gives us our number of pieces of data. I told you that was going to be very important. Here it is. So when we add up that column, that's what this is saying, that's going to give us that N. So this is just another way of writing N. So these two pieces data right here, these things right here are the same. All right, this is okay? So our number of pieces of data. Okay, so those are the two formulas. We're going to see how we're going to use them, all right? So first things first, let's start off with the basic. Given the raw data, here's the raw data they're giving us. They want us to find the mean. First things first, we need an N. Remember, whatever raw data they give us, that's your N. So my N here equals 1, 2, 3, 4, 5, 6. Again, remember, just add that up. So it's 6 here, okay? Now using the formula at the top, the X bar equals the sum of X all over N. That's our basic formula when they just give us a list of raw data. So we have X bar equals, okay? We're going to take and add up all of the data items they give us. So we have 1 plus 7 plus 3. Go right down the list. Plus 2 plus 5 plus 9. All over this N we just found when we added up those values to see how many we had. 6. Right? So now, of course, you can do all of this in your calculator. That's fine. You can take your calculator, put all those values in there, and do all your work in your calculator. No problem. Just be careful when you're doing it. So here we're going to add all this goodness up. You add all that up, you should get 27 all over 6. Then do your division, and 6 goes into 27, not evenly, but reduce your fraction. So in your calculator, and this one, in your scientific calculator, you should have a S to D or F to D button. So when you go ahead and put your information in, you get 27 divided by 6, and it will give you 4.5. You want to keep it as a fraction, that's fine. Reduce it. What you'll do is push your F to D button. So you have a F to D, or you'll have an S to D button. It's usually on a face button, or in some calculators, it may be in a second function. If you have a graphing calculator, it's in your math button, and it's called frac, F-R-A-C for fraction. It's your first choice. Then you would click that and push enter twice, you're fine. Okay, so most calculators have it on a face button. You'll push it, and then it will give you a reduced fraction of 9 over 2. Or your decimal of 4.5. All right, so this is your simplified fraction. This is your decimal. We know this, but I'm just writing it just in case. Why is it important? Because in the homework or on the test, they may ask you to write it as a simplified fraction, or they may ask you to write it and round your answer to something. So if they're going to ask you to round it to something, then you're going to have to use the decimal number and then round it to the appropriate place. So it's going to be very important that you know how to round. It's going to be important that you know how to simplify. These are basic math things, okay? If you need some help with these, then make sure you go to the Learning Commons and ask them. They have plenty of handouts to refresh you on rounding, to refresh you on how to simplify your fractions. But again, you have a calculator that can do it for you. All you have to do is Google the model of your calculator and ask the question, how do I simplify a fraction in my calculator? And there's a video out there that can help you, okay? Or we can Zoom each other and you show me what model calculator you have and I can help you as well, okay? All right, So now we've gotten our mean out of the way. All right. Now let's look at it given the frequency distribution table below, find the mean. So let's say they give you this frequency distribution table. They are going to give it to you in the homework. It says data items. We have that 1 through 5. The frequency, here's our frequency. We need to find the mean. First of all, tell me what my n is. Pause the tape and find your n. Okay. So you should have found your n. Remember, to find your n from the frequency table, we're simply going to add up the frequency column. So your n equals whatever this column adds up to be. So we have 10, 20, 22, what did you get, 24? Okay, I got 24. So we know what our n is. Now using the formula up at the top, so right here, why do we know? Because we're talking about frequency in there, right? So this is the mean of a frequency distribution table. So we're going to use x bar equals the summation of x times f all over the summation of f. That's our formula. What are we missing? We have our n, or our total number of f. So to add up f is 24. That's what the denominator is. So this is our that's our denominator. Okay? Now, what we need to do is find the numerator. The numerator says that we need to multiply x times f and then take all those values and add them up. So we need to create a column here that's going to give us that. We need to multiply these two rows together so that we can find those values. So this is going to be our x times f column. I'm just going to draw some lines here. Okay, so I got a new column now. So here's f, x times f. So now, if it makes you feel better, we know we're going to multiply across. Put the multiplication sign in between here if it makes you feel better. All right, this is all up to you, okay? We're multiplying these two columns together to create this new column. All right, so here we are. 1 times 5, 5. 2 times 7, 14. Does everybody see what we're doing? Okay, pause the tape and finish it up. Okay? All right, so now here we are. Finishing up, we should have a 6 here. 8 times 4 gives us 32, and then 5 times 2 is. Now we gotta sum it all up. So down here, we need the summation of all of this. So when you added it up, what did you get? Okay. Right? You should have gotten 67. All right. So the total of this column is 67. This is our numerator of our fraction. So now we have the top and the bottom. Now we can fill it in and we can find out what our mean is going to be. So let's do it. So now we have x bar equals 67 all over 24. This is our exact answer that we found. All right. That's our exact answer. But now, put it in your calculator. Can it be simplified? Try it. 67 over 24? I don't think so. Gave us 1.125 is what you should have gotten. Then change it to a fraction, and it does a simplified fraction. And it doesn't give us a simplified fraction. It does 9 over 8. Okay, so 9 over 8. Okay, so our exact answer, 67 over 24. So our reduced is 9 over 8. Right. What if they ask us for an approximate answer? Our approximate answer, when we put that in the calculator, we said that 67 over 24, did I put the wrong thing in there? Divided by 24. I did. I put the wrong thing in there. 67 over 24. What did I put in there the first time? Oh, I know what I did. I pushed the wrong button. Won't that happen to you? 67 over 24. I need to recant this answer. So I put the wrong thing in the calculator the first time and got that reduced fraction. Doesn't exist. So I put an 8 instead of a 7. I knew something wasn't right. Okay, so our exact answer, our approximate answer, okay, and they'll use like little squiggly equal signs for approximate answer. When we put it in our calculator, that's whatever comes out of your calculator. Like the whole entire funky decimal is your approximate answer. So once you put it in your calculator, they ask you for the approximate answer, then you're going to put whatever comes out of your calculator. And what comes out of my calculator is 2.791. And you verify with yours, 6666. I need another 6 and a 7. That big old funky decimal. All right. That's our approximate answer. Now this is where they can start asking you to round your answer or approximate it to a certain place. So if they want you to approximate it to 2 decimal places, all right, so to do 2 decimal places, then that would be, here's 2 decimal places would be the 9, right? So remember, the number right behind it is below a 5. So that means that we don't take any action on the 9. So that would be a 2.79, right? Okay. But what about approximated to 3 decimal places? So if we're rounding to 3 decimal places, then 3 decimal places would be at the 1. But look, right behind the 1 is a 6. That's above a 5. So that means we need to take action on that 1 and round that up 1 place. So what we get, 2.792. That's a 9, right? So 2.792. So again, watch where they're asking you to round. Watch what they're asking you how to put your answer into the homework. Watch how I'm asking you to do it on the tests or on any assignments. All right, so again, we're going to be doing a lot of that in this particular class. All right, so we found the mean. All right, let's move to the median. The median. So the median now says it's the middle of the set of ranked data. And this word right here is the key. So the middle of a set of ranked data. So your data has to be put in order for you to find the median. This is the only one that has to be that way. So they give you some data. Here's some data, and they want us to find the median. First things first, we got to put it in order from least to greatest. So here we start off with 0, then 1, 2, 3, 4, 7, and 9. Now, I always go back and count to make sure I have everything. It's better to be safe than sorry. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm good. Okay? Now, the value that is right in the middle. So we've already ordered, right? Our data. Now we're going to get the value that's right in the middle. This value 3 is right in the middle of our data. So the median is 3. All right. So our median is 3. It's really easy when you have an odd number, right? So we have an odd number of data. That's really nice. Let's look at this next one. So we have this set of data. We're going to put it in order. So we have 0, 1, 2, 3, 4, and 5. So 3, 6, 6. Okay. Now, if you look right here in the middle, there is no number right here in the middle. So we have 2 values, one on each side of our middle, right? So when we have an even number of data, it doesn't mean that we don't have a median. What we have to do now is we have to take the average of those 2 values now. So we got to find the mean, right? So find the average. So we have 2 plus 3 divided by 2. So 5 divided by 2. And there's our median. So (5/2), or If you want to write it as a decimal, again, they may ask, then that would be 2.5. All right. So we found the median. All right. Now let's look at the mode. The mode is most frequently most frequently occurring. Is that too hard here? My pen is getting out. Most frequently occurring piece of data. So when we look at the mode, we're looking at or for the piece of data that occurs the most. There's a couple of modes. We have one mode. If it has one, it's just a mode. If it has two modes, it's called bimodal. 3, trimodal. Okay? Sometimes it won't have a mode. It's okay. Let's take a look. We have this first group of data. We do not have to order this. We're just simply looking to see which number occurs the most. We see here we have 0, 3, 2, 7, 6, 2. Right off, I see a 2 here and a 2 here. So the mode is 2 because it's the number that occurs the most. All right, let's look at the second one. So we have 4, 6, 2, 6, 4, 7. So I see 2 4s going on here, and I see 2 6s going on. All right, so I see here that our mode, we have 2 of them. So our mode is 4 and 6. All right, so which we call bimodal. So bimodal data. You could have more than one mode. Okay. All right, look at the next one. You have 1, 2, 3, 4, 5. Do you see anything repeating there? Nope. So none or no mode. Okay. D. Watch it now. Let's see. We have 1, 2, 2, 3, 3, 4, 5, 5. I see a lot of repeating numbers. I see some 2s, see some 3s, see some 5s. Looks like we got a lot of things going on here. So our mode is 2, 3, and 5. Right? So 2, 3, and 5. None of them outbeat each other. So if there was 3 5s, then we know our mode would be just 5. But all 3 of these numbers appear twice. So our mode is these 3 numbers, which we call trimodal data. Right? So trimodal. Okay. All right, so E is corresponding to this frequency table that they give us up here. So we have our data items. You notice that they are colors, and here's the frequency for which they appear. All right, so tell me what you think the mode is for this frequency table. Remember, mode is the most frequently occurring piece of data. So we look at our frequency table, we see clearly that what color appears the most. Looking here, we see that brown appears the most, right? So our mode is brown. Why? Because it appears 5 times. All right. F. Here's another frequency table. Here's our data items 0, 1, 2, and 3. All right. Tell me what is my mode based on this data in this frequency table. Okay. We can clearly see that the number that appears the most is 1 because it appears 7 times. So our mode here is 1. So just being able to read our frequency table to see what our mode is, what number appears the most. Very easy. All right. This last part here with our mid-range. So the mid-range. How do we get it? We have a little formula. So we have the smallest plus the largest value all divided by 2. And that's going to give us our mid-range, right? So they're going to give you some set of data, and then you're going to find the mid-range. So you don't have to put this in order or rank it. You just simply need to identify your smallest value plus your largest value and divide by 2. So looking at this number 7, this set of data, calculating our mid-range, the smallest number we have is 0. Plus the largest number they gave us here is 7 divided by 2 gives us 7 over 2. Or writing it as a decimal, you get 3.5. That's it. All right, what happens if they give us a stem and leaf plot? So if we haven't seen this for a while, let's talk about it. So stem and leaves. So with the stems, stem and leaf plot is just a condensed version of writing numbers. So you have stems, which represent your tens place, all right, and the leaves represent your ones place. Okay, all right. So when we're reading our stem and leaf plot, here in our first row we have a 1. And then the leaves we have 0, 2, 4, and 7. This tells me that we have the number 10, 12, 14, and 17. In the second row is a 2. That means that we have 21, 26, 28, and another 28. You see how we're doing that. So a tens place is just that. So we know our places of our numbers. We have ones, tens, hundreds, thousands. And then we have places after our decimal. When you're dealing with stem and leaf plots, you're only dealing with your tens and your ones places. Okay, at least in this class, that's all we're going to do. Okay, so here they're asking us to list out our data. So when we list out our data from our stem and leaf plot, that's exactly what we're going to do. We're going to go row by row and pull the information out. So we have 10, 12, and separated with the comma, 14, 17. Going to the next row, we have 21, 26, 28, and 28. The third row, 32, 32, 35. In the fourth row, 40, 41, 48. So here's all of our data that was given to us in this stem and leaf plot. All right. So now that we've pulled that information out, now they want us to find the mid-range. The mid-range, again, is the smallest number plus the largest number divided by 2. Here's already an order for us. You know what the smallest number is. We can see it right here in the table. We see that 10 is our smallest number. 1 and 0 is 10. And our largest number in our data is 48. Okay? So our smallest is 10. Largest is 48. To find our mid-range, here we have 10 plus 48 divided by 2. We get our calculator and we do the magic. So we have 10 plus 48, which you know is 58, divided by 2. And 58 divided by 2 is 29. So our mid-range for this set of data is 29. Right? So now we've looked at how to find our measures of central tendency when giving just simple list of raw data, using our frequency table, our stem and leaf plots. Hope this helps you get through the homework. Make sure you, again, reading the directions of the homework and following what they're asking you to do. All right, good luck with everything. See you in the next video.